given that dy dx equals to 1 minus xy squared and that y equals to 1 when x equals to 0, the first three terms of the Taylor series are a 1 minus x plus x squared on 2, b 1 plus x minus x squared on 2, c 1 minus x minus x squared on 2, d 1 plus x plus x squared on 2. Let's find out which of the letters is the right answer. To get the first three terms of the Taylor series, it means that we should carry a Taylor series expansion of this differential equation. The formula to obtain the Taylor series expansion of a differential equation, or to obtain an approximate solution of a differential equation using the Taylor series, is given as y equals to y naught plus x minus x naught all into dy dx all that naught plus x minus x naught all that bracket squared all over 2 factorial all into dy squared all over dx squared all that naught plus I can continue up to the term with x minus x naught cube. So I decided to stop at x squared because the options given in the equation, all of them are having highest power of 2. So there is no need for me to continue up to x minus x naught cube. In this expansion, x naught is equals to 0 and y naught is equals to 1. That is, x naught and y naught are the values of y and x given in the equation. You see, in the expansion, I also need to calculate dy dx naught. The differential equation from the equation is dy dx equals to 1 minus x y squared. So to get dy dx naught, I need to set this differential equation at naught. So if this is naught, then automatically the x here will also have naught and the y here will also have naught. That is just the method. Now this means that dy dx naught is equals to 1 minus, that's into x naught, which is 0, times y naught, which is 1, all the squared. And here now you see I will have 1 minus 1 square is 1. 1 times 0 is 0. So it means dy dx naught is 1. That is 1 here. I need to also calculate the second derivative of y. That is the square y all over dx squared. The differential equation was dy dx is equals to 1 minus xy squared. If I differentiate this equation one more time, I will have d square y dx squared. That is, when I differentiate 1, I have 0. Now to differentiate this product, I need to use the formula of the differentiation of products. That is, if I have a product uv and let's say I want to differentiate this product with respect to, let's say, x, I will use the formula u dv dx plus v du dx. You see, if I take x here to be u and y squared, let's say, to be v, then this differentiation will be minus x dy squared dx. This minus affect all this product plus y squared dx dx. That is it. You see, in this term, I'm differentiating y squared with respect to x, which looks abnormal. The normal thing was I should differentiate x with respect to x, not y with respect to x. Anytime I differentiate y with respect to x, I'll write dy dx beside the differentiation. That is the method. And you know that if I have a function, let's say y equals to x to the n, to differentiate y with respect to x, I will have n x to the n minus 1. This is the main formula of differentiation. So you see, in this case, the function is y squared. So when I differentiate y squared, I'll have 2 minus 1, which is y to the power 1. That's, I'll have 2y. Since I'm differentiating y, I'll write beside dy dx. Means that here I'll have 0 minus bracket 2y. You see, x was beside this differentiation, so I'll write 2yx dy dx. And now here is plus y squared. You know, when I differentiate x with respect to x, it is 1. So here I will have y squared times the differentiation of x with respect to x, which is 1. That's all into bracket. Now you see, this minus multiplies all what is inside the bracket. So I'll have here negative 2yx dy dx negative y squared. It means the second derivative of this equation is negative 2yx dy dx minus y squared. That is, here I have negative 2yx dy dx minus y squared. But my target is to look for d square y dx squared, or that not. So to look for not, I have to put a bracket here and I put not here. And if I put not here, it means that here will be y naught, x naught, and all this bracket here will be dy dx naught, and here will be y naught. I need now to substitute y naught, x naught, and then dy dx naught in this equation to have d square y dx squared naught. That is, in the place of y naught, I will have negative 2 into 1, because y naught was 1. That is 1, and then into x naught, which is 0. dy dx naught is 1 as I calculated earlier, so minus 1 all that squared, since y naught is 1. Now I have to simplify this. Minus 2 times 1 times 0 times 1 will give 0. You see, 1 square is 1. So here I will have minus 1. So the square y all over the x squared is negative 1. So here the right answer is minus 1. Now I've gotten all the parts of the expansion. That means the Taylor series expansion of this differential equation is 1 plus x minus x naught is 0, all into dy dx naught, which is 1 plus into x minus 0 all that squared all over 2 factorial, all into minus 1 bracket plus and others. You know, d square y dx square is minus 1. That's why I'm having minus 1 here. Now simplifying this, I will have x minus 0 is x times 1 is x. So all this will be 1 plus x. You see here, x minus 0 is x, and then that's x squared times this minus 1 is minus x squared all over 2 factorial. 2 factorial is 2 times 1, which is the same as 2. So it means that this term will give me negative x squared all over 2 plus others. So it means the Taylor series expansion of this differential equation is 1 plus x minus x squared on 2 plus others. And if you go through these options, you will see that it's this one. So it means the right answer here is B.